All right, we're going to do some extra proof practice for my pre-AP students. So I'm on, if you have the unit packet, Polygon packet page 25, then you are in the right spot. So what are we going to do? Starting on problem 2 on this page, okay? You are given that XRV, angle XRV, which is this one, is congruent to angle RST. RST is this big angle up here. And you know that RSV is this one, is congruent to angle TVS. All right, so what does that mean? Well, first of all, on normal, I'm going to do a 2-column proof, but I'm going to skip writing the givens. Assume that the givens are written down just for space, okay? Well, if these two angles are congruent, then you have a transversal right here that connects the two corresponding angles. Do you see how this line and this line are touching the corresponding angles? They're making the corresponding angles with this transversal. Since the angles are congruent, the lines must be parallel. So I can write down my first conclusion after the givens is that TS is parallel to VR. And the reason is corresponding angles are congruent. Now the other thing I can take is I see that this angle is congruent to that angle. So my transversal that connects, remember the transversal connects the two angles, is this one. The two parallel lines in this problem is that one and that one. Because they are congruent, that's why I was able to say they're parallel. What kind of angle pair is that? That's alternate interior angles. So now I can say TV is parallel to SR. And again, that's because of alternate interior angles are congruent. Or I could have said congruent alternate interior angles. All right. Now that I know this, I can definitely say that RSTV is a parallelogram. All right. Why? Well, one of the conditions for a parallelogram, we just said that this is parallel to this, and we have these two are parallel. Opposite sides are parallel. Now let's move to problem 3. Given ABCD is a parallelogram, prove that FBCE is a parallelogram. When I first did this problem, I struggled a little bit because I forgot to pay attention to that. So let's pay attention to all our givens. It will make our life easier. Parallelograms, the important thing is that opposite sides are congruent and that they are parallel. I'm going to go ahead and just do my parallel symbols here. And it's kind of hard for me to show the congruent symbol on this set, FD and AC, because I have it kind of cut into segments. So I'm going to hold off on that for a moment, okay? So I have these two are congruent, and they tell me that, well, and I can also say this angle for sure is congruent to this angle. I don't really want to draw my angles here because I'm trying to prove that this is a parallelogram, and it's not going to really use that whole angle. So let me hold off on that marking. Now, if you didn't have this little tidbit, the extra trying to prove it that this is a parallelogram would be quite difficult. So here they tell me AFB is congruent to ECD. Okay. Well, now that I know that, well, you don't really have alternate anything, right? So you don't have that, but do you see I have two triangles here? I have triangle AFB and triangle DCE. Those two triangles have to be congruent. Triangle AFB is congruent to triangle DCE. And why is that? Because they have an angle, a side, and an angle congruent. So that's by the angle, side, angle. All right? Well, if those are congruent, then guess what? These are congruent, right? Those are congruent because corresponding parts of congruent triangles are congruent. CPCTC. CPCTC. All right, okay. Then that means that this is congruent to that, also by CP/CTC. AB is congruent to ED by CP/CTC. All right. Which means, if I wanted to, I could actually go with the angle here, have angles congruent. And you're like, well, that's still a little iffy. But if you look at the angle addition postulate, FE plus this, the segment addition postulate, FE plus ED is the same as AB plus BC. Well, we just figured out these two are the same, right? That means that FE and BC, I'm going to just do that to save space, have to be congruent because of the segment addition postulate, and plus substitution. I'm kind of skipping some steps only because I'm running out of room, and substitution. Okay, so what I was kind of saying is that FE plus ED equals AB plus BC. We already said that. That's because they're congruent. And we just figured out that these two are the same. So I could just call them X, right? So FE plus X equals AB plus X. Well, if I subtract X from both sides, the length of FE equals the length of AB. Therefore, they're congruent. So there's the side work that I was doing to show that. All right, we're almost done with these proofs on this page. Show that this is a parallelogram, OJKM. So they say OJM is congruent to KMJ. Already you can see I have an alternate interior angle pair. So I can say this is parallel to this. JO is parallel to KM. And the reason is alternate interior angles are congruent. All right. Then they tell me angle K is congruent to angle O. All right. Angle K is, well, what does that mean? I'm actually going to jump and think, wait a second. Look, I've got some more triangles here. Angle, angle, side. So I can say triangle KMJ is congruent to triangle, I started on the double, OJM. Always start on the same angle, the corresponding angles. All right? And the reason is angle, angle, side. All right? So that's the reason. Okay, so what does that mean? Well, then corresponding sides are congruent, right? And these corresponding sides are congruent. I don't even need to know parallel, right? Because opposite sides are congruent. This is a parallelogram. So I'm going to go ahead and say JO is congruent to KM, and JK is congruent to OM, and that's by CP/CTC. Corresponding parts of congruent triangles are congruent. Then, since those opposite sides are congruent, I can say JOKM or OJKM, doesn't matter, JOKMK, there we go. I should go in order, is a parallelogram. And that is because opposite sides are congruent. And again, I'm assuming quadrilaterals on all of these problems. All right, next, I can actually prove this is a rectangle, by the way. So, but first of all, I'll prove it's a parallelogram. This is a circle. That means this is a radius, that's a radius, that's a radius, that's a radius. I'm going to kind of shorthand this. I'm going to say SO is congruent to RO is congruent. Actually, you know what? I'm going to do it this way. SO is congruent to OP, right? And MO is congruent to OR. And I'm just going to say definition of a radius, right? Aren't all radii congruent? It's equidistant, and it's on the circle. So these are all radii. Or you could say all radii are congruent in a given circle. If it was a different circle, we're talking different things, all right? So that makes sense. All right, well, since these are bisected, then that is a parallelogram. I'm actually going to go ahead and jump. What I also know is that SP is congruent to MR. Aha, why is that? Well, the diameter should be congruent. They don't change as you go around a circle. Well, that tells you that SMPR is a rectangle. Doesn't matter how you do it. If you do two diagonals in a circle, you're going to get a rectangle. And that is because diagonals are congruent. And that's it.